Good afternoon, everyone. So today we will read Determinants section 4.3, 4.4 and do some example on that topic. Okay. So at first we see how we calculate area of triangle using determinants. Then we do some example to calculate area of triangle. And then we see what is minor and cofactor. Okay. So consider a triangle with vertices x1, y1, x2, y2, x3, y3. Okay. And how we can calculate this area of triangle? So the formula is 1 by 2. We already familiar with this formula. That is when we have to calculate area of a triangle and we know the all three vertices, then its area is given by this formula, that is 1 by 2 mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Okay. But how we can calculate area of triangle using determinant? So the expression above can also be written in determinant form. That is, area of triangle is equal to 1 by 2 determinant of 3 cross 3 matrices whose rows are x1 y1 1, x2 y2 1, x3 y3 1. Here x1 y1 is the first point, x2 y2 is second vertices, third x3 y3 is third vertex. So the above expression is written in the form of determinant. When we expand this determinant and find its determinant value by using the expansion formula, we get exactly the same formula of area of triangle. And always remember, area is always taken as a absolute value. Okay. So the proof is area of triangle is equal to, we write it in the form of determinant 1 by 2 into determinant of the matrix of order 3 cross 3 whose columns and rows are x1 y1 1, x2 y2 1, x3 y3 1. So expanding the determinant along row r1, then so we know how we expand. So just take first element of the row 1, that is x1, and then multiply it with okay. So when we multiply, when we find the determinant of that matrix, we get exactly the same equation as we already familiar to find the area of a triangle. Okay. Since area is a positive quantity, we always take the absolute value of the determinant. If the area is given, we use both positive and negative value of the determinant for calculation. But always remember, area is always a positive quantity. Now, when we see points are collinear, collinear means all the points lie in a same line. So, 3 points that are x1 y1, x2 y2 and x3 y3 are collinear, that means lie on a same line if the area of triangle formed by them is 0. So if we imagine, we can see if the area of triangle is 0, then it means the all three lines lies on a same line. So they are collinear. So to prove 3 points are collinear, we just need to find area of triangle formed by them, and if it is 0, then lines are collinear. That is 1 by 2 and a matrix determinant of the matrix of order 3 cross 3. And if we see the rows of the rows of this matrix, the first row is x1 y1, that is the first point, and then constant 1, and then second row represent second point, and third row represent the third point, and the last column is just 1 1 and 1. Okay, so that's how we can find area of a triangle whose vertices are these 3 points. Just calculate the determinant of this matrix. And if it is 0, then these all 3 points are collinear. So the condition for collinearity is to find the determinant of the matrix x1 y1 1, x2 y2 1, x3 y3 1, and if it is 0, then points are collinear. Okay, find the area of triangle whose vertices are 3 8 minus 4 comma 2 and 5 comma 1. Okay, now we have 3 vertices, so just apply the formula and find the area of triangle. Okay, so we need to find the area of triangle whose vertex are 3 8 minus 4 comma 2 and 5 comma 1. And we know that the area of triangle with these 3 vertices can be calculated using determinant, that is area is equal to 1 by 2. First row represent the first point x1 y1 1, and then x2 y2 1, x3 y3 1, and area is always taken as the absolute value. So the area of triangle is given by 1 by 2. First vertex is 3 8, so in place of x1 just put 3, for y1 8 1, then minus 4 2 1, then 5 1 and 1. Okay, and just find the value of this determinant and multiply with 1 by 2. We get the area of the triangle with vertices 3 8 minus 4 comma 2 and 5 comma 1. So expanding along R1, so we get 1 by 2. As we already familiar how to expand to get the determinant, we just take first element 3 and then determinant of matrix of order 2 cross 2, which obtained by cancelling first row and first column. So we get 2 1 1 1, and determinant of 2 1 1 1 is 2 minus 1. Similarly, we get minus 8 into minus 4 minus 5 plus 1 into minus 4 minus 10. So when we simplify, we get 1 by 2 into 3 plus 72 minus 14, that is 61 by 2. Hence, determinant is 16 by 2. So the area of triangle with vertices 3 8 minus 4 comma 2 and 5 comma 1 is 16 by 2 square units. Okay, so by using determinant we can easily find area of triangle just calculating a determinant of order 3 cross 3. Okay, so example 7 is find the equation of the line joining A 1 comma 3 and B 0 comma 0 using determinant. So at first we have to find the equation of line of joining 2 points are given. So we also use the concept of how to find equation of 2 points that we already read in class 11th, but here we have to find using determinants. Okay, and then find k if the point K0 is a point such that area of triangle ABD is 3 square unit. So at first find the equation of line with point A and B, and then find value of K if these 3 points make a triangle whose area is 3 square units. Okay, so try. Okay, so at first part we have to find the equation of line joining points A, that is 1 comma 3, and B 0 comma 0, and we have to use the concept of determinants to find the equation, and then we have to find the value of K, and it is given that area of triangle with vertex A, B and D is 3 square units. As we know, the area of triangle with vertices x1, y1, x2, y2 and x3, y3 can be calculated using a determinant, that is area of triangle is equal to 1 by 2 determinant of first point and 1, x1, y1 1, x2, y2 1, x3, y3 1. Just calculate its determinant and multiply with 1 by 2, we get the area of triangle. Now expanding the determinant along first row, so we get area of triangle as 1 by 2 x1 into y2 minus y3 minus y1 into x2 minus x3 plus x2 y3 minus x3 y2. Okay, we just expand along R1. So for the third point 1, we calculate the determinant of the matrix. When we cancel third column and first row, we get determinant of matrix x2, y2, x3, y3, and its determinant is x2, y3 minus x3, y2. 3 points are collinear if the area of triangle formed by them is 0. We use this concept to find the equation of line joining A and B. As we know the area of triangle, how to calculate using determinant. Okay, and also we have a concept collinear, is that when we calculate area of triangle formed by the collinear points, the area is 0. So if we take another point on the line A, B and another point, then the all 3 points are collinear because all are present in the same line. So the area formed by them is 0. So we just use this concept to find the equation of line. Okay, that is the condition for collinear, that is determinant of 1 by 2 into determinant of x1 y1 1, x2 y2 1, x3 y3 1 is 0. Okay, so when we use this concept, let's consider another point on a line AB, that is P, X, comma, Y. Then area of triangle by ABP is 0. Why? Because all three ABP are present on a same line. So area of triangle formed by this three line, first line is 0, 0, 1, that is the coordinate of B. Then coordinate of A is 1, 3 and 1. And coordinate of P is X, Y and 1. So we written all the 3 points. Now we calculate, as these are collinear, so is equal to 0. So when we expanding the determinant along row 1, why we expand along R1? Because there is 2 0 present on that row. So calculation is more easier if we consider any other row and columns. Okay. So when we expand, we just need to calculate 1 by 2 into for the last element of that row, that is 1. So 1 into determinant of the matrix of order 2 cross 2 by eliminating the first row and third column. As I say, if we want to find the matrix of order 2 cross 2, by which we have to multiply with that element to find determinant, just cancel the row and column in which the element is present. So 1 present in third column and first row. So when we cancel the first row and third column, we get the matrix 1, 3, xy, and determinant of that matrix 1, 3, xy is y minus 3x. Okay. So it's equal to 0. So when we simplify, we get y is equal to 3x, which is the equation of the required line AB. Okay. Now first part is completed. Now we have to calculate the value of k, and the known value is area of triangle formed by this 3 point ABD is 3 square unit. So just apply the formula for area of triangle with points A, B and D. So we get 1 by 2, 1, 3, 1, 0, 0, 1, K 0, 1 is equal to plus minus 3. As I already mentioned that if we have to calculate, in calculation, we have to take both positive and negative value of determinant. Okay. So we get, just calculate determinant of 1, 3, 1, 0, 0, 1, K 0, 1. We get minus 3k by 2 is equal to plus minus 3. We get a linear equation with one variable, and when we simplify it, we get k is equal to plus minus 2. Okay, and that is the value of k. So now we read some property related to determinant. So first property is the value of determinant remain unchanged if its row and columns are interchanged. So it says that if in a determinant in a matrix, if we change its row and column, interchanged it, that means row become column and column become row, then the value of determinant remain unchanged. So we already familiar with the concept of transpose of A. So what is transpose of A? If there is a matrix A and if we interchange its row and column, then that matrix is called transpose matrix, and it is noted as A dash, and according to the property number 1, the determinant of matrix A is equal to determinant of transpose. So we can prove it. Just consider general matrix of order 3 cross 3, that is with element A1 B1 C1 A2 B2 C2 A3 B3 C3. So when we transpose it, the row A1 B1 C1 become its first column, that is A1 B1 C1. The second row of the matrix A become the second column of the transpose matrix, that is A2 B2 C2, and the third row of matrix A become the third column of the matrix A transpose, that is A3 B3 C3. So at first we find determinant of matrix A. So just expand along R1. So A1 multiply with determinant of matrix order 2 cross 2 by cancelling first row and first column. So the matrix is B2, C2, B3, C3, and its determinant is B2, C3 minus B3, C2. In similar way, when the minus sign come with, the indices is minus 1 the power I plus j, that is 1 plus 2, that is 3, that is odd. So we get minus here. So minus into B1. Then multiply with determinant of matrix by cancelling the second row, second column and first row. We get A2 C3 minus A3 C2. And for the third element C1, plus sign, because indices is 1 comma 3, 1 plus 3 is 4, it is even, so we get plus sign, plus C1 into multiply with determinant of matrix A2 B2 A3 C3, that is obtained by cancelling first row and third column. So we get A2 B3 minus A3 B2. Now expand A dash along R1. So along R1, first element is A1, then A2, A3. By in similar way, we calculate determinant of A bar. On simplifying, we get this. Rearranging term by grouping A1, B1, C1, we rearranging in such a way such that when we compare the determinant of A and determinant of A bar, we see that determinant of A is equal to determinant of A bar. Okay. So any property of determinant that is true for row is also true for column. That is remark, if we read any property for rows, then that property is also true for columns. Now, property 2 is, if any two row or columns of a determinant are interchanged, then the sign of the determinant changes. So, if you take any two row and just interchange it, or if take any column and just interchanged, then sign of determinant change. If it is positive, then it become negative, and if it is negative, it become positive. So what it means is, by if you take a determinant of order 3 cross 3, A1 B1 C1, A2 B2 C2, A3 B3 C3. So when we expand along R1, we just apply the formula for calculating determinant and we get determinant of that matrix. So now consider another determinant, delta 1, be the determinant obtained by it interchanging R1 and R2. So in this matrix we can see the R1 row become R2 and R2 row become first row. Okay, so we just interchanged it. So now we expand for this determinant along R1, we get A2 into first element is A2, and then a determinant of, by cancelling first and second, first column and first row, we get B1 C3 minus C1 B3, and second element is B2 with sign minus, A1 C3 minus C1 A3 plus C2 A1 B3 minus B1 A3. So rearrange terms to match the original expansion. We get determinant 1 is equal to minus A1 into B2 C3 minus C2 B3 plus B1 A2 C3 minus C2 A3 minus C1 A2 B3 minus B2 A3. So taking negative sign out, we can see that when we take negative sign out, the expression left is exactly the same as the determinant of original matrix A1 B1 C1 A2 B2 C3 A3 B3 C3. So determinant of matrix delta 1 that is obtained by it interchanging R1 R2 is equal to negative sign minus into determinant of original matrix. So when we changed any two rows of determinant, then just sign of determinant changes. Just verify property 2. For determinant 2 minus 3 5 6 0 4 1 5 minus 7. So when we expand along R1, So first element is 2 into determinant of 0, 4, 5, minus 1, that is 0, minus 20. Then minus into minus 3. Then determinant of matrix. Cancel first row and second column. The matrix is 6, 1, 4, minus 7. So it becomes minus 42 minus 4 plus third element 5 with determinant 6 into 5 minus 0. That is 30 minus 0. So it becomes minus 40 plus 3 into minus 46 plus 150. That is, so the determinant value for this matrix is minus 28. So now interchanging R2 and R3, we just interchange the row R2 with row R3. So now R2 become row 3 and row 3 become row 2. So now we expand along the row with R1. So we get first element of the row 1, 2 into determinant of the matrix which is obtained by cancelling first and first column, first row and first column. So we get 5 minus 10, 0, 4, and determinant for that is multiply the diagonal element minus off diagonal element. So we get 5 into 4, that is 20, and 0 into minus 7 is 0. Similarly for just minus, because in SSS is 1, 2, and that is 1 plus 2 is odd. So we get minus into minus 3 into determinant of matrix 1, 6, minus 10, 4. That is obtained by cancelling second row, first row and second column. So it becomes 4 minus 42 plus 5 into 0 minus 30. So determinant of matrix, new matrix is 40 plus 3 into 46 minus 150. That is 28. So we can verify the property 2 is that when we interchanged any 2 row or any 2 column, we have to change the sign of determinant. It just changes the sign of determinant. For the first, determinant with negative sign, and when we interchange, we get a determinant value is 28. Okay. So verified. Now, property 3 is if any 2 rows or columns of a determinant are identical, so all corresponding elements are the same, then value of determinant is 0. So property 3 says that if there is any matrix in which any 2 rows or columns are identical, it means all corresponding elements are the same, then determinant of that matrix is 0. So let's say we have to calculate determinant with 2 identical rows, that is R1 and R2. So determinant of this matrix where the first row and second row is identical because all corresponding elements are same, just A1, A1, B1, B1, C1, C1. So when we calculate its determinant, so just apply the property 2. What is property 2? If any 2 rows of determinant are interchanged, the sign of the determinant changes. So interchange the 2 identical row, R1 and R2. Just understand how we prove this. We use the property 2 to prove the property 3. In this determinant, we just interchanged first and second row. Okay. So just sign of the determinant changes. And when we interchange these 2 identical row R1 and R2, let the new determinant be delta 1. But the determinant of delta 1, that is new determinant, is same as delta because R1 and R2 are identical. So it doesn't matter how many times we interchange this, we get exactly the same determinant as delta 1. Okay. So when we observe the new determinant, since we interchange 2 identical rows, determinant delta 1 exactly the same as the original one, as I already mentioned. So delta 1 is equal to delta. Now we have 2 equation. Using property 2, delta 1 is equal to minus delta. And when we observe determinant, we have a property that delta 1 is equal to exactly the same. So from this 2 equation, we get delta is equal to minus delta. that is 2 delta equal to 0. So determinant is 0. Okay, so that is your property 3. It says whenever there is a we have to calculate determinant in such a way that two rows or columns are identical, that is all the corresponding elements are same, then determinant value is 0. Okay, so now we evaluate the determinant of 3, 2, 3, 2, 2, 3, 3, 2, 3. So we need to find determinant of the matrix 3, 2, 3, 2, 2, 3, 3, 2, 3. We can observe here that the row R1 and third row are identical. So according to the property 3, the value of determinant is 0. So we can also verify it. Just expand it along R1. We get 3 into determinant of matrix 2, 3, 2, 3, that is 6 minus 6. Then minus sign, then 2 into determinant of matrix, just cancel second column and first row, we get a matrix 2, 3, 3, 3, that is 6 minus 9, plus third element into determinant of matrix, just cancel third column and first row, we get 2, 2, 3, 2, and determinant of 2, 2, 3, 2 is 4 minus 6. So we get 0 minus 2 into minus 3 plus 3 into minus 2, that is 6 minus 6, and that is 0. So determinant property 3 says that if in a matrix in determinant there is two rows or column are identical, then the value of determinant is 0. Now property number 4 is if each element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. Okay. So property 4 says that if there is a determinant and we multiply any row or column by a constant k, each element of that row or column by a constant k, then the value of determinant is just get multiplied by k. So let's consider a determinant of order 3 cross 3, that is a1, b1, c1, a2, b2, c2, a3, b3, c3. Now expand along r1 to get determinant of that matrix. We get the determinant is a1, b2, c3. We just expand along the first row. Okay, now let determinant delta 1 be the determinant obtained by multiplying the row r1 by a constant k. So we get a new the new determinant, the new matrix obtained by just multiplying the first row with constant k. We get k1, kb1, kc1, a2, b2, c2, a3, b3, c3. Now we calculate determinant for this. So now expand delta 1 along r1. So we get ka1 into b2c3 minus b3c2 minus second element is b2 kb1. So kb1 a2c3 minus a3c2 plus kc1 a2b3 minus a3b2. So factor out the constant k. We get k, then into just factor out k, and we get the exactly the same expression as delta. The recognized expression in the bracket is exactly the same as the determinant of the a1, b1, c1, a2, b2, c2, a3, b3, c3. So determinant of new when we multiply by r1 by k is equal to k into determinant of a1, b1, c1, a2, b2, c2, a3, b3, c3. So according to property 4, when we multiply a determinant by a when we multiply each element of row or column by a constant k, then value get multiplied by k. Okay, so determinant property 4, this means we can take out any common factor from any one row or any one column. So by using the property 4, it says that if there is a determinant and we want to factor out any constant term for each row, if there is present is 2 into 3, 3 into 2, and 4 into 2, then 2 is present on the all in the row, so we can take it out from row and column. And that is a difference with matrices. If K is the matrix where every element is multiplied by K, and if A is order n, then determinant of Ka is K the power n into determinant of A. Okay. This is different from multiplying only one row or column. Property 5 says that if sum of all elements of a row or columns of a determinant are expressed as a sum of 2 or more terms, then the determinant can be expressed as a sum of 2 or more determinants. So, determinant property 5 says if there is a determinant, as we can see here, the first row is written as sum of 2 terms, a1 plus delta 1, b1 plus delta a1 plus lambda 1, b1 plus lambda 2, c1 plus lambda 3. Okay, a2, b2, c2, a3, b3, c3. So now we can, then this determinant can be expressed as sum of 2 or more determinant. So we can express the determinant in sum of 2 determinant. And the determinants are, just taking the first, for a1 and lambda 1, just take a1 and write a1, b1, c1, a2, b2, c2, a3, b3, c3 plus the second term of the sum, lambda 1, lambda 2, lambda 3, a2, b2, c2, a3, b3, c3. So the second row and third row does not affect it, but according to the sum present in the first row, we just distribute it into the 2 determinant and convert into the sum of 2 determinants. Okay, we can prove it. Just expand the LHS determinant along R1. So the LHS part of determinant is a1 lambda 1 plus b1 lambda 2 plus c1 lambda 3, a2 b2 c2, a3 b3 c3. So LHS is equal to a1 plus lambda 1 into b2 c3 minus b3 c2 minus b1 plus lambda 2 a2 c3 minus a3 c2 plus c1 plus lambda 3 a2 b3 minus a3 b2. Distribute the terms, we get this expression. Okay, just distribute the terms. First multiply with a1 and then lambda 1. Now recognize each bracket part as an expanded determinant. The first part is determinant for this matrix a1 b1 c1 a2 b2 c2 a3 b3 c3, and the second part of the bracket is the determinant of matrix a lambda 1 lambda 2 lambda 3 a2 b2 c2 a3 b3 c3. So adding 1 and 2, we get RHS part. Okay, so LHS is equal to RHS. Now property 6 is if each element of any row or column of a determinant, the equimultiples of corresponding elements of other row are added, then the value of the determinant remains the same. Okay, so this property 6 says that if each element of any row, take any row or any column, just take a row, and equimultiplies of corresponding element of other row are added. So just take any row and any another row and multiply that row with any constant and add it to that row. We get a new row, then the value determinant remain the same. We just understand by the, in other words, if your determinant perform an operation where we take a row, multiply each of its element by a number and add the result to the corresponding element of another row, we get a same determinant. That is, the value determinant remains same if we apply the operation. That operation is R1 is changed by R1 plus KRJ. So here is one row, first row is R1 and second row is RJ. Just understand property what is property 6 says. Okay, so it is some trick. So we take first row R1 and RJ and we replace R1 Ri by Ri plus constant equimultiples of corresponding elements of other row, that is Rj. So Ri is replaced by Ri plus KRj. Similarly, if we take any column Ci, we replace Ci by Ci plus constant multiple of any other column Cj. So if we perform this operation, the determinant remain the same, and that is property 6 says. Okay, let's prove it. So we have taken determinant a1 b1 c1, a2 b2 c2, a3 b3 c3. Lambda determinant after applying the lambda determinant after applying the operation. So operation is taken first row and the first row become a1 b1 c1 become r1 plus k into r3. So a1 b1 c1 plus k into row 3 is a3 b3 c3. So if we perform this operation, the determinant remain the same. That is property 6. We just prove, we try to prove it. Okay, so now my r1 become taken first element a1 and add first multiply the r3, that is a3, with k and add into r1. So we get a1 plus k into a3. Understand what is the operation? We just take an element of r1 and add the corresponding element on r3, multiply with k and add into r1. So we get a1 plus k1 a3, b1 plus k b3, c1 plus k c3. And that is we get a new determinant. We have to calculate this determinant of this matrix, and that property number 6 says that the determinant remain the same. Okay, so apply property 5. What is property 5? Property 5 says that if sum of all elements of a row or columns of a determinant are expressed as a sum of two or more terms, then determinant can be expressed as a sum of two or more determinant. Okay, so now we split determinant 1 as the first row is written as a1 plus k3, second row second element of that row is b1 plus k b3 plus c1 plus k c3. So now we split it according to property 5. So lambda delta 1 become a1 b1 c1, a2 b2 c2, a3 b3 c3 plus determinant of the matrix ka3 k b3 k c3, a2 b2 c2, a3 b3 c3. Okay, the first determinant is lambda. In the second determinant, take the common factor k from R1 using property 4. What is property 4? Property 4 says that if each element of row or column, there is a row R1 of a determinant is multiplied by a constant k, then its value gets multiplied by k. So for the second determinant, if we calculate, we just multiply with the determinant with k. So k into determinant of a3 b3 c3, a2 b2 c2, a3 b3 c3. Just carefully observe the second determinant k into the matrix a3 b3 c3, a2 b2 c2, a3 b3 c3. In the second determinant r1 r3 are identical. So also we have property 3 is that if two rows are identical, then determinant is 0. So lambda 1 is equal to lambda plus k into 0 into lambda 1. So lambda 1 is equal to lambda. That is same as the original determinant. Okay. So now here is another concept on determinant is that minors and cofactors. Okay. So in this section, we will learn to write the expansion or determinant in compact form using minors and cofactor. So what is minor and cofactor? So first is minor. So the minor of an element, just imagine the matrix. So there is an element Aij, that is element of the ith column and jth row, ith row and jth column. So the minor of an element Aij of a determinant is the determinant obtained by deleting the ith row and jth column. So minor is itself a determinant. Okay. And what the determinant of a matrix, that is obtained by deleting the ith row and jth column. So when we are calculating determinant of order 3 cross 3 and expanding along any rows or column, and when we multiply with that element, that matrix of order 2 cross 2 is nothing but the minor. Okay. So for any element, minor is calculated as deleting the ith row and jth column, denoted as Mij. For minor is calculated for a particular element. For each element on that matrix, we have a minor for that, and that is capital Mij. Okay. So let's consider a determinant delta 1 is equal to a1 b1 c1 a2 b2 c2 a3 b3 c3. The minor of first element a11, that is a1, denoted as capital M11. So just cancel first row and first column. We get a matrix b2 c2 b3 c3, and determinant of that matrix is your minor 1 1. Similarly, for element a12, the minor m12 is remove one first row and second column. We get a2 c2 a3 c3, and determinant of this is called minor m12. So minor of an element of a determinant of order is a determinant of order n minus 1. So what is this remark says? This remark says, if we have a determinant of order n, just like his order is 3, so the order of the minor is n minus 1. As we can see, the order of m11 is, order of that determinant is 2 cross 2, that is 2. So n minus 1, that is 2. Okay. So in this question, we have find the minor of element 6 in the determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to calculate determinant minor of the element 6. Okay. So we need to find the minor of element 6 in the determinant, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 present in the second row and third column. So its indices are 2, 3. So we have to calculate minor for the element a23. Okay. So the minor is m23. So the minor m23 is obtained by just remove second row and third column. So we get a matrix a1 b1 a3 b3, and here a1 is 1, b1 is 2, a3 is 7, and b3 is 8. So when we calculate determinant of this, we get 8 minus 14, that is minus 6, and that is minor of the element 6. So minor is related to a particular element of the determinant. Okay. Now second term is cofactor. So what is cofactor? The cofactor of an element, cofactor is also defined for a particular element of a determinant, denoted by Aij, and is defined by Aij equal to just multiply minus 1 the power I plus j into Mij, where Mij is the minor of Aij. Okay. So if we calculate the minor, just multiply with minus 1 the power I plus j, where I plus j is indices of the element for which we have to calculate the cofactor. Consider this matrix a1 b1 c1 a2 b2 c2 a3 b3 c3. So minor of a11 is denoted as capital M11. Just cancel first row and first column. So we get b2 c2 b3 c3, and its determinant is called minor. And when we multiply it with minus 1 the power I plus j, that is 1 plus 1, that is the cofactor a11. Okay. So cofactor are nothing but just minors with positive and negative sign according to the minus 1 the power I plus j. So minor of A12 is, remove first and second column to get the value of minor 1, 1, 2. Now, and cofactor A12 is, multiply with it, minus 1 to the power 1 plus 2. So we get minus M12. Cofactor of A23 is minus 1 to the power 2 plus 3, that is M23, minus 1 into minus 6, that is 6. So, by using the concept of minor and cofactor, the value of determinant is sum of product of elements of any rows or columns with the corresponding cofactor. So now we can represent a determinant as sum of product of elements of the corresponding cofactors, because cofactors are minus 1 to the power I plus j into mij, where mi is determinant of that matrix of order 2 cross 2, that is obtained by cancelling first and i's and second j's rows. Okay. So when we expand along R1, the determinant is become A1 into capital A11 plus B1 into capital A12 plus C1 into capital A13. The cofactor element Aij is noted by Aij is defined by minus 1 to the power I plus j into minor Mij. So here is given a determinant. So minor of A11 is denoted as M11, just cancel first row and first column. We get B2 C2 B3 C3, and when we multiply with minus 1 to the power I plus j, that is minus 1 to the power 1 plus 1, we get M11. In a similar way, we get a cofactor A12 and A13. So we calculate cofactor for all the element. Okay, so by using the minor on all the elements, by which we get by removing that row, ith row and jth column, and then multiply with minus 1 to the power I plus j, we calculate the cofactor of all the elements. So when we expand along R1, we get A1 into, so here we can see that B2 C2 B3 C3 is the minor M11, and the second term minor M12, and for the third term minor M13, and when we compose with negative and positive sign, we get determinant as A1 into A11 into B1 into A12 plus C1 into A13. Okay. So if an element of row are multiplied with cofactor of any other row, then their sum is 0. So this property says that if there is an element and we multiply with that cofactor of any other row and column, then sum is 0. So just verify it. Okay, we see how we calculate determinant by using cofactor and minor, and we see also some properties of determinant. Okay, so let's do exercise 4.2 of determinant. So the first question is, we have to find the area of the triangle with vertices at the point given in the following. So there is 3 question and the vertices of a triangle are given. So we have to calculate the area of triangle. So just first recall the formula, how we can calculate area of triangle. So to find the area of triangle given it vertices, we can use the formula area is equal to 1 by 2 mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 into y1 minus y2. And we always take absolute value of the area, and the given vertices are x1 y1, x2 y2 and x3 y3. Okay, so also we can use determinant of matrix to find area of given vertices. So To find area of triangle using determinant, we can use the formula of calculating area as 1 by 2 in determinant of this matrix x1 y1 1, x2 y2 1, x3 y3 1. Okay, here the first row represent your first vertex, then second, and then third. So if we are given 3 vertex and we have to calculate area of triangle, so then we using by the formula, and we can also use determinant to find the area of triangle. Okay, so now we have two method. So try to find the area of this triangle. So given vertex are 1 0, 6 0 and 4 3. So by using method 1, for this vertex we can assign x1 y1 as 1 0, x2 y2 as 6 0, x3 y3 as 4 3. And now plug this into the formula, and the formula is area is equal to 1 by 2 mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So just plug into the formula, we get area is equal to 1 by 2 1 0 minus 3 plus 6 3 minus 0 plus 4 0 minus 0. Just calculate, so we get 1 by 2 mod 1 minus 1 into minus 3 plus 6 into 3 plus 0. That is 1 by 2 mod minus 3 plus 18, that is 15 by 2. And that is area of the triangle by using method 1. Okay. Now we apply method 2 to calculate area of triangle, that is using determinant. So 3 vertex are x1 y1 is 1 0, x2 y2 is 6 0, x3 y3 is 4 3. And when we apply the area of a triangle by using determinant, that is 1 by 2 determinant of x1 y1 1, x2 y2 1, x3 y3 1. That is 1 by 2 1 0 1, 6 0 1, 4 3 1. So when we calculate area, that is 1 by 2 0 mod 0 6 1 4 1 minus 0 1 1 4 1 plus 3 1 1 6 1. We just expand along column 2 because there is 2 zeros present. So we choose column 2 to expand. So the first term and second term become 0. So we only need to calculate determinant 3 into multiply determinant of 1 1 6 1. Okay. That is 1 by 2 0 minus 0, 3 into determinant of 1 1 6 1. Just multiply the diagonal element minus diagonal of off diagonal element. So 1 into 1 minus 1 into 6. So area is become 1 by 2 mod 3 into 1 minus 6. That is 1 by 2, 3 into minus 5, that is 1 by 2 into 15. So we get 7.5, that is area of the triangle. So by using the both method, we get the same area. Okay. Now, second part of the question is, we have a given vertex 2 7 1 1 10 8. Just apply the method and try to find the area of the triangle. Okay, so given vertex is 2 7 1 1 10 8. So we have just assigned x1, y1 as 2, 7, x2, y2 as 1, 1, and x3, y3 as 10, 8. Plug this into the formula. So we get area is equal to 1 by 2 mod x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. So when we plug into the values into this formula, we get 1 by 2 mod 2 into 1 minus 8 plus 1 into 8 minus 7 plus 10 into 7 minus 1. So just simplify it, we get 1 by 2 mod 2 into minus 7 plus 1 into 1 plus 10 into 6. So just simplify, we get 1 by 2 into 2 into minus 7, that is minus 14, plus 1 into 1, that is 1, and 10 into 6, that is 60. Just do a normal calculation, we get 47 by 2. That is the area of the triangle. Now we apply the method 2 by using determinant to calculate area of the triangle. So we just assign x1, y1 is 2, 7, x2, y2 is 1, 1, x3, y3 is 10, 8. So determinant is equal, area is equal to 1 by 2 determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. So just set up the determinant, substitute plug the values of x1, y1, x2, y2 and x3, y3, we get 2, 7, 1, 1, 1, 1, 10, 8, 1. So now we need to calculate determinant of this 3 cross 3 matrix to calculate the area of the triangle. So just expand along row 1. So we get 1 by 2, 2 into determinant of 1, 1, 8, 1, that is obtained by just cancelling first row and first column. Then minus 7 minus because of the indices 1, 2, that is 1 plus 2, that is odd, so we get minus 10 here. So minus 7 determinant of 1, 10, 1, 1, that is obtained by just cancelling second column and first row for the last element 1, then 1, 1, 10, 8. So now we need to evaluate determinant of this all 2 cross 2 matrix. So we get 1 by 2, 2 into 1 minus 8, minus 7, 1 minus 10 plus 1, 1 into 8 minus 1 into 10. That is 1 by 2, 2 into minus 7, minus 1 into minus 9 plus 1 into minus 2. So when we simplify, we get 1 by 2 in mod minus 14 plus 63 minus 2, that is 1 by 2 into 47, that is same as the previously we find using that formula. So we get 47 by 2, that is 23.5. That is the area of the triangle. Okay. Now third part is, we are given the vertices, just try. Okay, so given vertices are minus 2, minus 3, 3, 2, minus 1, minus 8. So for this we can assign as x1, y1 as minus 2, minus 3, x2, y2 as 3, 2, x3, y3 as minus 1, minus 8. So plug this into the formula. The formula is this: 1 by 2 x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. So areas become 1 by 2 mod minus 2 into minus 2 plus 8 plus 3 into minus 8 plus 3 plus minus 1 into minus 3 minus 2. So when we just simplify it, due to the mod sign, minus 30 become 30 and 30 by 2 is 15. That is area of the triangle. Now we apply method 2 of determinant to calculate the area of the triangle. So to set up determinant, x1, y1 is minus 2, minus 3, x2, y2 is 3, 2, x3 y3 is minus 1 minus 8, and area is equal to 1 by 2 determinant of x1 y1 1, x2 y2 1, x3 y3 1. So substitute the given vertex. We get area is equal to 1 by 2. In place of x1, that is minus 2, then minus 3, 1, 3, 2, 1, minus 1, minus 8, 1. So just calculate determinant to calculate area. So minus 2, minus 3, 1, 3, 2, 1, minus 1, minus 8 determinant is just expand along R1. So you get minus 2 determinant of 2, 1, minus 8, 1. Then minus 3, 3, 1, minus 1, 1. Plus 1, 3, 2, minus 1, minus 8. That is minus 2. Determinant of 2, 1, minus 8, 1. That is multiplication of product of diagonal element minus product of diagonal element. Okay. So just apply the formula in all three matrix of order 2 cross 2. We get determinant as minus 30. Okay. Therefore, area of the triangle is 1 by 2 minus 30, that is 30 by 2, that is 15 square units. That's the area of the triangle. Okay. So question number 2 is, so that these points A, B plus C, B, B, C plus A, and point C, that is C, A plus B, are collinear. So how we can show points are collinear? Can we relate with area of triangle? Just think and try to solve. To show these 3 points are collinear using determinant, we need to show the area of triangle formed by these points is 0. So if for any 3 points, area formed by them is 0, then points are collinear. The formula for area of triangle is area is equal to 1 by 2 x1 y1 1, x2 y2 1, x3 y3 1. If the points are collinear, the determinant will be 0. So the given points A is A in A B plus C, points B is B comma C plus A, and point C is C comma A plus B. So the area become first point A, then B plus C, x1 y1 1, x2 y2 1, x3 y3 1. Just plug the values from the points. Now we calculate determinant of this 3 cross 3 matrix. We can use the first column for expansion. So we expand along column 1. So first element is A, then just cancel first row and first column to get the matrix C plus A1, A plus B1, and then minus B. Why minus? Because of indices, that is 2 comma 1, and 2 plus 1 is 3, that is odd. So we get minus B. Then we get a matrix B plus C1, A plus B1, and similarly for the third element, that is C, B plus C1, C plus A1. Okay. So A into determinant of the first 2 cross 2 matrix. So just multiply C plus A into 1 minus A plus B into 1. Then minus B, B plus C into 1, A plus B into 1, plus C, B plus C into 1 minus C plus A into 1. Just simplify. A, C plus A minus A minus B, minus B, B plus C minus A minus B, plus C, B plus C minus A. So we get A into C minus B, C minus A, plus C, B minus A. That is, just break the bracket. So we get AC minus AB minus BC plus AB plus BC minus AC. Now let's combine terms. So we get AC minus AC plus minus AB plus AB plus minus BC plus BC. So all are cancel out. So we get 0. Since the value determinant is 0, the area of triangle formed by this point is 0. Therefore, the points A, B and C are collinear. Okay. Now, we have to find the value of K if area of triangle is 4 square unit and vertices are K0, 4, 0 and 0, 2. So, first method is using determinant. The area of triangle with vertices x1, y1, x2, y2 and x3, y3 given by this formula. Okay. And here is given the area of triangle is 4 square unit. We just need to calculate the variable K. And we know if area of triangle is given and we have to use it for calculation, we take both sign plus and minus. So it become 1 by 2 x1 y1 1 x2 y2 1 x3 y3 1 is equal to plus minus 4. Now we use this for the calculation of the calculating value of K. This implies determinant of x1 y1 1 x2 y2 1 x3 y3 1 is equal to plus minus 8. So we need to consider both positive and negative value because determinant can be negative, but the area is always positive. Okay. Second method is to find the value of K that makes the area of triangle equal to 4 square. We can use formula of area of triangle given by vertices. I first recall you how we can calculate the first determinant using determinant or using this formula to get the value of K. Okay. First method is using determinant and second method is using the basic area formula. That is the formula is this. So now try. So let first point x1 y1 as K0, x2 y2 as 4 0, x3 y3 as 0 2. So apply method 1. Method 1 is of determinant. So area is equal to 1 by 2 x1 y1 1 x2 y2 1 x3 y3 1. Set up determinant. So we get 1 by 2 K0 1 4 0 1 0 2 1. And as area is given 4 square unit, so we take plus minus 4 because we use area for calculation. So we get K 1 2 get on the RHS side, so into 4 into 2 that is 8. So K0 1 4 0 1 0 2 1. Now we calculate determinant of this matrix of order 3 cross 3. So expand determinant using the column second column, we get 0 into 4 1 0 1 minus 0 into K1 0 1 plus 2. Determinant of K1 4 1 is equal to plus minus 8. So we get first two terms become 0. So we only left with 2 into K into minus 1. K into 1 minus 1 into 4 is equal to plus minus 8. So now we have equation with one variable. So we get, so just divide by 2. We get K minus 4 is equal to plus minus 4. Now we have two possible cases. First one is, case 1 is K minus 1 is equal to 4. So K is equal to 4 plus 4 and that is K is equal to 8. And second case is K minus 4 is equal to minus 4. That is K is equal to minus 4 plus 4. That is 0. So we have two possible cases for K, that is one is 0 and one is 8. Now we apply method 2. So we use this area formula. So just plug into this formula. We want the area to be 4. So we get 4 is equal to 1 by 2 K 0 minus 2 plus 4 into 2 minus 0 plus 0 into 0 minus 0. So is equal to 4 is equal to 1 by 2 mod minus 2k plus 8 mod. So it becomes 8 is equal to mod minus 2k plus 8. When we further simplify, this absolute value equation can be split into two cases. First one is minus 2k plus 8 is equal to 8. Or second one is minus 2k plus 8 is equal to minus 8. So case 1, minus 2k plus 8 is equal to 8. That is minus 2k is equal to 0. So k is equal to 0. Now case 2, minus 2k plus 8 is equal to minus 8. That is minus 2k is equal to minus 16. So k is equal to 8. So the value of k for which the area is 4 square unit are k is equal to 0 and k is equal to 8. Now the fourth question is find equation of line joining 1, 2 and 3, 6 using determinant. Okay, so just try. So line joining 1 and 2 and 3 and 6, we have to get equation for this line segment. Okay. So to find the equation of line joining 2 points x1, y1, x2, y2 using determinants, we can use the concept that the area of triangle formed by 2 points and a variable point x1, x and y on the line is 0. Because if 3 points are present on a same line, that means they are collinear. So using the concept that for the collinear points, the area of triangle formed by these 3 points is 0. The amount of form for this is 1 by 2 xy1 x1 y1 1 x2 y2 1 is equal to 0. We just take us one point xy on the same line and using the concept of collinear so that we can get the equation of this line. So plug these points into the determinant, we get 1 by 2 xy1 y1 2 1 3 6 1 0 is equal to 0. So now we calculate determinant of this. So multiply to both sides and expanding the determinant, we get x into 2 minus 6 minus y into 1 minus 3 plus 1 into 1 minus 6 minus 2 into 3 is equal to 0. That is x into minus 4 plus y into 2 plus 6 minus 6 is equal to 0. That is 4 minus 4x plus 2y is equal to 0. Dividing the entire equation by 2 to simplify, we get minus 2x plus y is equal to 0. Thus the equation of line joining 1, 2 and 3, 6 is y is equal to 2x. And that is the equation of the line. Okay. So that's all for today. Thank you.